Dear students, today we're going to be we're going to be going over lesson 3.3. Now, before we go over any of this, let me first explain the learning objectives. We have to identify power functions. We have to identify the end behavior of power functions, identify polynomial functions. Last but not least, identify the degree and leading coefficient of polynomial functions. Now, this might sound misleading and a bit challenging, but trust me, it's very, very simple. Now, starting off with the first objective, which is just identifying power functions. Now, what is a power function? A power function is simply written in this form, where f of x equals to k multiplied by x raised to the power of p. Let me give you an example of a power function. Let's say f of x equals to x squared. Now, what is p in this case? P equals to 2. What is the coefficient? The coefficient is the number multiplied by x squared, which is k. K equals to 1. Now, k can be equal to 2, it can be equal to 3, and so on. Let's have a look at this, where k and p are real numbers and k is known as the coefficient. And when they mention the word real numbers, it means that p can be a non-integer. Let me give you an example. F of x can be equal to, let's say k is a negative number, it can be -2, multiplied by x. P can be 1/2. It doesn't have to be an integer, it can be a decimal. Doesn't have to be an integer. And yeah, that's pretty much it for power functions, like understanding what a power function is. Let's have a look at the following examples, I believe. Yeah, let's have a look at example number 1. And let's determine which of the following are power functions. Now, having a look at the first one, we have f of x, which equals to 1, which is simply x raised to the power of 0. So p equals to 0. And what is k? K equals to 1, right? And this is definitely a power function since it's written in the form of k multiplied by x raised to the power of p. Now, what about the second one? F of x equals to k, which is simply 1. K equals to 1. And we have x raised to the power of 1, which means that p is 1. So k is 1 and p equals to 1. What about this? K equals to 1. We have x squared, so p equals to 2, which is totally fine. It's written in the form of a power function. Same with this cubic function. We have x cubed, k is 1, p is 3. What about this reciprocal function? If I take 1 divided by x and I turn it into a function, I just want to have a base of x and I don't want a fraction. This is x raised to the power of -1, right? So p equals -1 and k equals to 1. What about this one? We have x squared, which is x raised to the power of -2. K is 1, p is -2. And this is x 1/2. And this is simply x 1/3. All good? And these are all power functions. You can have p, as I've mentioned, as a decimal, which is 1/2, which is totally fine. It can be 1/3, which also works. Now, what about these functions? Which functions are considered as power functions? Looking at the first one, if I were to simplify this, f of x equals to 8 times x to the power of 5, right? Now, k equals to 8, p equals to 5, which is definitely a power function. We have k times x raised to the power of p, which is definitely in this form after you distribute 2x squared. Now, what about g of x? Can I simplify g of x any further and turn this into kxp? I don't believe so. because you can't really add these like terms. So that means it's not a power function. You have 3 different terms, and I only want one term. Remember, with a power function, it can only be one term. It cannot be 3, 2, or more terms. Now, what about h of x? Now, let's simplify h of x. This is 2x5 divided by 3x squared plus 4. And what about -1? Let's write that down. Divided by 3x squared plus 4. Now, this is 2 terms as well, which is definitely not a power function. Now, let's have a look at this. Okay, now let's understand the end behavior of power functions. Now, what do I mean by the word end behavior? It means that when x tends to negative infinity and when x tends to infinity, what happens to a function? Now, they're telling us with this that k is positive. So let's form a function where k is positive. Let's assume that k equals to 1. Remember, it's k x p. So if k is 1, I'm just going to write down 1. And they want an even power. Power, let's say, equals to 2. So let's say f of x equals to x squared. Now, when x tends to negative infinity, what happens to f of x? Let's plug this in. Negative infinity squared, right? I'm plugging in negative infinity into x squared. Now, what is negative infinity times negative infinity? This simply equals to infinity, right? Because negative and negative cancel out. Infinity times infinity is just infinity. So f of x does, in fact, tend to infinity when x tends to negative infinity. Now, what about this one? When x tends to infinity, what happens to the function? Let's plug in infinity into x squared. We have infinity multiplied by infinity, which is just equal to infinity, which is in fact, let me erase this, which is in fact the case as well. I don't want you to memorize any of this, I just want you to understand how infinities work when plugging them into functions. Now let's have a look at the odd power. Let's say I have an odd power with a positive constant. So can you remind me of the power function form? It's simply k x p, right? Let's say k equals to 1, p equals to 3. So now I have x cubed. Now let's plug in the first one as x tends to negative infinity. What do I get for the function? Well, if I have negative infinity cubed, what is this equal to? Isn't it simply negative infinity times negative infinity times negative infinity? Now, what is this equal to? Well, what is negative times negative? This equals to positive, right? Multiplied by negative, what do I get now? Negative, right? So negative infinity. Infinity times infinity times infinity is just infinity. Let's make sure you don't mess up with the signs. So negative times negative is positive times negative, which is negative infinity. Now what about this one? What about as x tends to infinity, what happens in this case? Well, it's going to be quite obvious. What is infinity cubed? It's infinity times infinity times infinity, right? We don't have any negatives, so 3 positives is just a positive. Infinity times infinity times infinity is just infinity, which is infinity in this case. I'm going to say this one more time, probably going to repeat it again. I don't want you to memorize this, I just want you to understand how functions and powers work. How end behaviors and power functions work. Let's say k is negative, so f of x equals to negative. We have an even power. We can go with x squared as well. So what happens in this case? Let's say x tends to negative infinity. I have negative of negative infinity squared. Now, negative is just negative, right? I'm going to keep this as it is. Now, what happens if I have an even power with a negative sign? So let's say I have negative 2 squared. This is 4, right? Negative 2 to the power of 4. This is 16. Whenever you have an even power, the negative sign cancels out. So 2 will cancel out the negative sign, and infinity times infinity is just infinity. So now I have this negative, which is this, and x squared, which is negative infinity squared, is just infinity. So negative times infinity is just negative infinity, which is in fact the answer. Now what if I have infinity plugged into f of x? So I have f of x times negative infinity squared. Well, this is also just negative infinity squared as well, which is just negative infinity. Oops. Which is in fact the answer as well. Okay, let's have a look at the last case. Now, what if I have x tends to negative infinity for k negative and an odd power? So f of x equals to negative x, odd power, let's say 3. So I have negative of negative infinity cubed. Now, if I have a negative sign and I have an odd power, the negative sign remains as negative. So negative. Now, infinity cubed is just infinity, so negative infinity. This is just negative infinity. Now, negative times negative is positive, so this equals to positive infinity, which is in fact the case. As x tends to negative infinity, you can tell that f of x equals to infinity, which is correct. Now, what about the last case? Let's test this out. I have f of x, which equals to negative x cubed, negative of infinity cubed, which equals to negative infinity, which is also the case. Okay, so that's pretty much it for these 4 cases. I do not want you to memorize this. Just understand how power functions behave with n behaviors. Now, describe the end behavior of the following function. This means that as x tends to infinity, what happens to the function? Well, f of x equals to infinity to the power of 8, which equals to infinity. Now, what if x tends to negative infinity of f of x of negative infinity to the power of 8? What is this equal to? Well, remember, if it's even, the negative cancels out, so it's equal to infinity, and that's it. So remember, if it's an even power, the negative sign will turn into positive. If it's an odd power, and then you have a negative sign, so let's say negative infinity to the power of 7, odd, negative remains as negative. Infinity multiplied by itself 7 times will just give you infinity, and that's it. You just need to understand how powers behave with signs, okay? And yeah, try and solve this one on your own right now. Pause the video. Once you're done with that, and we can solve it together. So if I have f of x equals negative x to the power of 9, let's say x tends to infinity, I have f of x, which equals negative of infinity to the power of 9, which is just negative infinity. Now, what about x tends to negative infinity? I have f of x, which is negative of negative infinity to the power of 9. Now, what did I tell you about this? If it's an odd exponent with a negative sign, it remains as negative. So negative infinity, and negative by negative is just equal to positive, which is positive infinity. And that's it. Okay, so try and solve this one on your own. If you have any questions, you can ask me in class. All good? Okay. Let's move on to polynomial functions, which is very simple, very, very simple. You see this every single day. Let me give you an example before we look at any of this. Let's say f of x equals 2x cubed plus 2x squared plus x. This is a polynomial function. It's a function in terms of x. And all the powers are non-negative integers. That's it. Do you see any negative numbers as a power? we have 1, 2, and 3. We don't have any negative integers, and we don't have any decimals as well. So let's say f of x, let's say it equals to x 1/2 plus x 1/3. This is not a polynomial function. Why? Because the powers must be positive. Let me write that down. It must be positive. All the powers must be positive, and they must also be integers. So keep that in mind. Integers and positive. So yeah, that's pretty much it for a polynomial function. And the number in front of x is simply called the coefficient. Every x has its own coefficient. And and the coefficient and the x would be considered a term. So this is really important. Let me write this down as well. So let's say f of x equals to negative x plus 4x squared. Do we usually write a polynomial function with the leading degree as the last term? No. You always write polynomial functions with descending powers, with decreasing powers. So let me show you what I mean. We need to always rearrange a polynomial function. In this case, you write the highest degree as the first term. So this is the leading term. This is the leading term, 4x squared. The second term would be negative x, since the next highest degree power would be 1, right? So 4x squared minus x, and let's say you have, yeah, that's it, and so on and so on. Let's say you have x cubed, x squared, and x. You would first do x cubed, then x squared, then x. Now let's have a look at example number 4 and determine which of the following are polynomial functions. Well, if I distribute this, I'm going to get f of x, which equals to 6x4 plus 4, which is definitely a polynomial function. Now what about this one? We have negative x. Now you may ask, well, what about 4? 4 doesn't have an x next to it. Well, it does. It's multiplied by x to the power of 0, which is just equal to 1, right? And 0 is a non-negative integer. It's not negative, and it's also an integer. Now what about g of x? This is negative x cubed plus 4x, which is definitely a function, polynomial function. What am I looking at? I'm looking at the powers. They are positive. They are integers, which means I'm dealing with a polynomial function. Now, last but not least, h of x, it's 5 times x 1/2 plus 2. I'm looking at the powers. They are positive. Are they integers? No. So that means this is not a polynomial function. Now, moving on to example number 5, identifying the degree and leading coefficient of the following polynomial functions. I want you to write down every single function, rearrange it first from the highest degree and in a decreasing order, basically, not increasing, decreasing. So I would first be negative 4x cubed, then 2x squared, and we have plus 3. G of t would be 5t5 minus 2t cubed plus 7t. Last but not least, h of p equals to negative p cubed plus 6p minus 2. Correct? Now, what is the leading term? It would be negative 4x cubed, the leading term 5t5, and then negative p cubed. What is the degree of f of x? The degree in this case is 3, the highest degree. The degree of this one equals to 5, and the degree of this equals to 3. And that's it. And leading coefficient is negative 4. Leading coefficient of g of t is 5. Leading coefficient of h of p is negative 1. And why is this important? It's important to rearrange every single polynomial function and understand what is the leading term, because that will help you find the end behavior, which brings us to this table. Now let's have a look at this polynomial function and let's understand what is the leading term. Well, it's rearranged for us, so that's a good thing. What's the highest degree? The degree of this function is 4. What is the leading term? It's 5x4. Remember, you take the coefficient along with the x. If you don't do that, you may end up with the wrong end behavior. Now, how do I find the end behavior? You first take x tend to infinity. F of x equals to 5 multiplied by infinity raised to the power of 4, which is simply 5 by infinity, which equals to infinity. Now, then you take, so this is the first end behavior. The second end behavior is as x tends to negative infinity. We have f of x, which is 5 times negative infinity to the power of 4, which is 5. Remember, if it's an even exponent, even power, the negative will cancel out, so it's simply 5 by infinity, which equals to infinity as well. Let's just double check our answers. We have as x tends to negative infinity. What did we get? We got f of x equals to infinity, which is in fact correct. Now as x tends to infinity, we also have f of x equal to infinity, which is also true. Now let's have a look at the second graph. We have the following function. You take the leading term. So we have f of x equals to negative 2x to the power of 6. You plug in x tends to negative infinity if you want as the first end behavior. You have negative 2, negative infinity to the power of 6. You keep negative 2 as it is. Now even exponent and negative, it turns into positive, right? So negative 2 times infinity is just negative infinity. Now what about x tends to infinity? We have negative 2 times infinity x6. This is negative 2 times infinity, which is just negative infinity.